Hello and welcome to my video on how to use the Pythagorean Theorem. So we're going to start by just a quick reminder of what the Pythagorean Theorem states. It states that in a right-angled triangle we have a hypotenuse here, and we always label that side C in a right-angled triangle, which means that the two legs of the triangle are going to be A and B. It doesn't really matter for the way that we're doing it in my class which side is going to be A or B, as long as you have the hypotenuse directly opposite of that 90-degree angle. And remember, this only works on a 90-degree angle. So through our explorations, we found that if we took a square off of side A, its area or its side length squared added to the area of a square off of the B face, those two areas added up to the area of a square made off of face C. So we got A squared plus B squared equals C squared. Now in order to use that in practice, I'm going to give you this quick example. So let's say that we've got side A is 10 units long and side B is, let's say, 12 units long. We're going to go and take those numbers, and so we're going to replace A with the 10, just like our algebra that we would have done. So 10 squared plus 12 squared equals C squared. So now we have to do that math. So we have 10 times 10, that's 100, plus 12 times 12 is 144. That gives me the area of that square that comes off of face C. So its whole area, 100 plus 144, is 244. And remember, that's the area of that full square. So in order to find out what the actual side length is, I have to undo this squaring of the number. So the opposite of squaring a number is the square root. So if I took the square root of 244, that's going to tell me what number multiplies by itself to get that answer of 244. So when I do that actual math, I get an answer of, hang on for 1 second, I'm going to use the square root button on my calculator here. I know you can't see that, but I'm doing that on the side. So I get 15.6 is an approximate value of the length of side C. So I could say that side C is 15.6 units long, whatever that is. So that's a basic way of how to find the length of the hypotenuse in a Pythagorean theorem. We'll talk more of how to find the missing side length another day.